Welcome to 5.5's Math Moment. Today students took time just to practice division. So there's not going to be any new concepts that they learned today in math class, but it was a really nice day for them just to get some extra practice with their long division using a 2-digit divisor out in the front of the division problem. So we're going to look just at a couple more examples so you have more to refer to as you're working with your student at home. So the first one is a word problem, and it says, Tolly the panda ate 41 pounds of food a day. The zoo has 329 pounds in the feed barn. How many days will this feed tally? So when I'm thinking about this problem, I needed students to think about how much do they have. All right, and this kind of takes us back to Unit 3 when we were dividing with fractions. We always think about first, what do we have? Okay, that's the number that we are going to be dividing from. Okay, I have 329 pounds and I want to make it work over a certain amount of days. And each day, she gets 41 pounds. So that's the same amount. That's equal groups. So I know that that's divide. Another way to think about that is students know that division with whole numbers makes things smaller. So would I want a really large amount of days for that to cover? Would that make sense? If I multiplied those two, I would get a really big number, and that wouldn't make sense with the question for the amount of days. So having your student kind of work through, should this answer be smaller or larger, sometimes can help them to figure out whether they should multiply or divide. But today we will divide, so it says 321 divided by 41. Now again, 41 is really hard for me to mentally think what the multiples are. So they might want to use an estimation strategy and really think about a number that might be a little easier for them to work with, which would be 40. I'm not going to divide my whole problem by 40. I'm just going to use 40 to kind of help me pick some numbers to try. So the first thing I need to think about is how many times can 41 go into 3? Because that's my first number. Students will hopefully see that 41 cannot go into 3. 3 is way too small. 41 is way too big. So I need to move on to the next set of numbers. How many times can 41 go into 32? Well, 41 is also too big for 32, so I cannot go into 32. So the next thing I'm working with is the whole number. How many times can 41 go into 329? Now, I'm not really sure, so I'm going to have to pick something to guess and check with. When I think about this 40, and I count by 4s, 4, 8, 12, 16, 20, 24, 28, 32, I start to get really close to this number 32. Okay, and I can see that that's in the beginning. So I might choose 1, 2, 3, 4, 5, 6, 7, 8 to try 41 times 8. Now maybe your student doesn't count by 4s and they don't see that pattern. That's okay too. Maybe your student starts by multiplying by 3 or by 4. Eventually they will see that they need to continue to get larger and go that way. So let's go ahead and stick with 41 times 8. 8 times 1 is 8. 8 times 4 is 32. And that gets me really, really close to 329. So that tells me that 8 is my answer. So using that estimation strategy and counting by 40s, because really this is just a 0 added on when I'm counting by 40s, really helped me to know, hey, I need to multiply by 8 instead of guessing and checking a lot and having to do a lot of math work. But if your student does not see this and does not want to use that strategy, they could guess and check until they're able to get close enough. So they're going to see that 41 times 3 is way too low. So maybe then they jump up to 6. Then they know that they need to get closer and closer. And eventually they will get to the 41 times 8, which gets me my best answer. So 329 minus 328 just leaves me with 1, which means that I would write my remainder as a fraction, or I need to go back to my question and think, how many days will this feed Tally the panda? Well, I need to think about how I need to use my remainder. If these are amount of days, does 1/41st of a day, does that really matter for my answer? Probably not. I'm probably going to just leave that off and give my answer as it's going to last her for 8 full days. Now example 2 says 9,434 divided by 89. So I'm going to go ahead and set that up as a long division problem. And again, I'm working with an 89. 89 is a really hard number to know the multiples of 89 in my head. 89 times 1, sure, I can do that. But 89 times 2, 89 times 3, that starts to get really difficult. So I know that I'm going to have to pull that to the side and work those problems out. But to help me know where to start, I could use estimation and round that 89 to 90 just to help my brain think about what can I maybe get closest to. So the first thing that I'm going to do is say, how many times can 89 go into 9? Well, 9 is too small, so I know 89 will not go into 9. So then I move on to 94. How many times can 89 go into 94? Hopefully students will see that 89 is pretty close to 94, and so I really only need to put that in one time. And then I'm going to go ahead and subtract 89. I'm going to borrow from the 9 to make that 14. 14 minus 9 is 5. 8 minus 8 is 0. Then I'm going to go ahead and bring down my 3. Now, the next problem that I have is 89. How many times can it go into 53? Well, 89 is too big for 53. So this is where students get really confused because they know that 89 cannot go into 53, but for some reason they struggle to put a 0 up on the top. So encourage them that if 89 cannot go into 53, I still need to place something. I have to put a number on top to account for that 3. So if it goes in 0 times, I put in a 0. So 0 times 89 is 0. I subtract and I'm still left with 53, and then I bring down the 4. So now I have a really big number that I'm working with, 534. That 90 is maybe going to help me with that. If students can count by 9s, they can count by 90s. Right, so I'm counting by 9s here to kind of help me get close to what my answer might be. Anytime that I'm counting by 90, if I count by 9s, then I'm just really adding a 0 to the back. So I can look here and use my estimation strategy to help me figure out where could I maybe get kind of close. Well, 540 is really close to 534, so maybe I should try 89 times 1, 2, 3, 4, 5, 6. Oh, excuse me, that should be 89. Right, so I can go ahead and try that. 9 times 6 is 54. 6 times 8 is 48. Plus 5 would give me 53. And that's awesome. It gives me exactly what I want, 534. So I get to put a 6 on top, and I get to put 534 on the bottom to subtract and get to 0. Now, if your student does not use the estimation strategy and this does not make sense to them, what strategy they might use is just a guess and check method, and that's okay. They will get the right answer. Maybe they think, well, I'm going to try 89 times 5 at first to see how close I can get to 534. When they do 89 times 5, they're going to see that they need to go a little bit higher. Maybe the next thing they'll try is 89 times 6, and then they'll see that they got exactly what they need. So if your student is one who really likes to take that divisor and just multiply it by lots of different things and do a guess and check model, encourage them to keep their work in case they need it again, but let them go ahead and use that model to help them because, again, it's multiplication practice, which is always great, and also they will get to the answer with that work. So if this estimation does not make sense to them, it's all right for them to use a guess and check model. If you have any other questions about 5.5, make sure to see your math teacher.